Okay, let's jump right into this explainer and uncover the totally invisible forces holding up the very building you are sitting in right now. When we look at a structure, we just see solid beams, concrete, and steel, right? It all looks so static. But beneath that quiet surface, there is this constant, violent war of physics happening every single second. Today, we're going to expose exactly what is going on inside those structural members.
Because here's the thing, beams don't just sit there peacefully. They are under constant, relentless attack from the weight they carry and the supports that hold them up. And honestly, one of the most destructive forces at play here is this unseen energy that's actively trying to slice the material right down the middle.
Section 1. Defining shear force. So, what is it? Well, at its core, shear force is an internal force acting parallel to a cross-section, and it's actively trying to make adjacent parts slide against each other. Imagine taking a deck of cards, right? You push the top half one way and the bottom half the absolute opposite way. That exact sliding action, that's what this force desperately tries to do to solid steel and concrete.
And since this force is totally invisible, engineers actually have to track it mathematically. They typically denote it with a capital V and measure it in newtons or kilonewtons. You basically figure it out by looking at all the vertical pushing and pulling happening on either side of a specific section. You just sum up those vertical forces and boom, you pin down exactly how much of that sliding energy is trapped inside the beam.
Section 2. How shear force acts.
It's really fascinating how this force is actually born. External downward loads, combined with upward support reactions, are what create these hidden internal forces. It's a total contradiction. You've got heavy weight pushing down in the middle, meeting supports pushing back up at the ends. And that direct head-to-head conflict is exactly what generates the intense shear force inside the member.
Imagine just taking a massive saw and cutting that loaded beam in half, right where those competing forces meet. The left part is forced up, while the right part is forced down. They act exactly like a giant pair of scissors sliding past one another. The two halves are perfectly balanced in the air, sure, but they are trying their absolute hardest to slide completely past each other. And yeah, nobody wants their building's foundation acting like giant scissors.
Which brings us to Section 3, the threat of shear failure. So we know the forces are in there, and we know they want the material to slide. But what does that actually mean for the beam itself? What's the physical toll?
The primary consequence here is that it produces intense shear stress. It literally attempts to cut the solid material from the inside out. All of that opposite upward and downward force generates just a tremendous amount of stress along the cross-section. The beam isn't just carrying weight, it is actively fighting against its own internal desire to shear cleanly in two.
And that leads to the crucial point. Every single material, whether we're talking wood, steel, or concrete, has a break